How do you find out if this triangle is a right triangle? In this lesson, you will learn how to classify a triangle by using the Pythagorean theorem. Let's review. The first triangle we're going to look at is a right triangle. And you can identify a right triangle because it has a 90-degree angle, which is indicated by the two little lines there. Another triangle is an acute triangle, and an acute triangle, all the angles of the triangle are less than 90 degrees. And the third triangle is obtuse, and you can recognize an obtuse triangle because one of the angles of the triangle is greater than 90 degrees. Another thing I want to go over is the Pythagorean theorem. So remember, we can use the Pythagorean theorem to find the length of sides for right triangles, and you can use either formula. A squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. Or you can use another formula, leg squared plus leg squared equals hypotenuse squared, and identifying the legs of the triangle and the hypotenuse. So either one you can use, it's fine. A common mistake that students make is they have a really hard time finding the hypotenuse sometimes. So if you're using the Pythagorean theorem and you're trying to figure out which side is the hypotenuse, a great way to find the hypotenuse is to look across or opposite from the 90-degree angle. So in this triangle, we identify the 90-degree angle, and the arrow is pointing to the longest side, which is also the hypotenuse. So if you had to set up an equation that using the Pythagorean theorem, you would set it up. 9 squared plus 12 squared equals 15 squared. Good. So looking at this triangle, how can we prove that this triangle is a right triangle? Well, we know that the Pythagorean theorem only works for right triangles, so let's identify the hypotenuse and plug these side values into the Pythagorean theorem. So I have a squared plus b squared equals c squared. So 41 is clearly the hypotenuse because 41 is the biggest number. So I'm going to write the Pythagorean theorem as 9 squared plus 40 squared equals 41 squared. And I put a question mark because we don't know if this is equal yet. So does 81 plus 1600 equal 1681? Yes. 1681 is equal to 1681. So therefore we can conclude that this is a right triangle. Here's our second triangle with side lengths 16, 14, and 7. So here we can clearly see the hypotenuse because it's the longest side, 16 inches. So I'm going to substitute the sides of the triangle into the Pythagorean theorem. I'm going to use a different formula than the one we did before, just so we're comfortable using both formulas. So we want to find out, does 7 squared plus 14 squared equal 16 squared? 49 plus 196, does that equal 256? No, 245 is less than 256. So if you end up having the legs squared to be less than the hypotenuse squared, then you know that you have an obtuse triangle. Let's try this third triangle. So once again, I'm going to write the Pythagorean theorem, and I'm going to identify which side is the hypotenuse, which here it's 13. And write our side values into the Pythagorean theorem. So 6 squared plus 12 squared, does that equal 13 squared? Does 36 plus 144 equal 169? And no, 180 is greater than 169. So this is different. Now, the legs squared are larger than the hypotenuse squared. So when you have something like this, you know that it's going to be an acute triangle. In this lesson, you have learned how to classify a triangle by using the Pythagorean theorem.